Morning geometry. Welcome back. Hope you all had a very relaxing, pleasant, and safe and healthy spring break. We're moving back into it. We're going to finish the chapter on Monday of next week, and then we're going to have a review on Wednesday, and your test is going to be on Friday. And then starting not next week, but the following, we're going to change things up a little bit because we're going to be done with curriculum. We'll talk about that later. It's going to be easy. It's going to be fine. Everything's going to be good. Please remember, if you have questions about anything, if you are curious about anything, if you're confused, if you just need to know what's going on with the school, with the class, just shoot me an email. And I'll respond. Today we're dealing with combinations. We talked about permutations last time. Permutations, remember, it's a way of arranging stuff where order matters. Combinations, they don't matter. Combinations, I've always said combinations are like pizzas. If my brother and I go to get a pizza, but I want basil, onions, garlic, and peppers on mine, but he wants peppers, garlic, onions, and basil on his, well, out of all the choices, it's the same thing. It doesn't really matter what we have on it because pizza's going to be the same either way. So that's what a combination is. Order doesn't really matter. Another thing is, let's say that in the class I ask 8 students to go run an errand, and I say I need these 5 things taken care of when you go run this errand. Doesn't matter who does it, doesn't matter the order, just make sure that they're done by the time you come back. Also, that's a combination of how things are done. So we use combinations. Let's say that we're talking about the pizza. Let's talk about pizza again. Let's say we have the combinations again. We have the combinations. And let's say that in a pizza, we have a choice of, let's say, 15 different toppings. But we choose 4 of them. Combination looks like that. Now, the formula for combination is a little bit different. Not completely, but a little bit different than that of a permutation. This is still NCR, like that. Let me make this N a little bit smaller. And in a combination, the formula is n factorial over n minus r factorial. That's the same, but we also have to have r factorial again. R factorial again. So let's say we're talking about this pizza. We're talking about having this pizza for, we have a choice of 15 toppings. We're going to choose 4 of them. We say 15 factorial over 15 minus 4 factorial times 4 factorial, which gives us, and I'm just going to make the whole thing right here, 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8, make this a little bit bigger so we can do this whole thing, times 7 times 6 times 5 times 4 times 3 times 2 times 1. That is 15 factorial. Everything over. 15 minus 4 factorial, 4 factorial. We have, we can also rearrange this to make it 4 factorial times, we're just going to say, times 11 factorial. And I'm just going to write these out as well. 4 times 3 times 2 times 1 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now we can see these all cancel out. Those all cancel out. Another thing we can cancel out, 4 times 3 and 12. So we're really just left with 15 times 14 times 13, everything over 2. Well, let's see. 15 times 14 times 13 is 15 times 14 times 13 is 2730 over 2 is going to give us 1365. So this right here, whole thing, turns into 1365. It's going to be smaller than the permutations because we're dividing by more numbers. Again, we can type this into our calculator. We can say 15 PRB, scroll over to NCR, NCR for 1365. It did it for us. We can type it in the calculator. We don't have to go through all of that stuff if we don't want to. But of course, me being the teacher, I have to actually show you how it works, and that's what that is. So we're going to do just one or two more, and then that'll pretty much be it for today. So we can have, let's say, 12C3. I'm going to abbreviate these. It's 12 factorial over 12 minus 3 factorial times 3 factorial. Okay, so this comes out to 12 times 11 times 10 times 9 factorial, everything over 3 times 2 times 1 times 9 factorial, because 12 minus 3 is 9 factorial. Those cancel out, and so we have 12 times 11 times 10 over 6. Those can cancel out. That can be 2, and this will give us 220. We look into the calculator again, clear it out. 12 PRB NCR 3 220. So that's how that one works. If we have another one where we're going to do, let's say, 20C5, we have 20 choices. We're going to choose 5 of them. It's going to be 20 factorial over 20 minus 5 factorial times 5 factorial, which comes out here to be 20 times 19 times 18 times 17 times 16 times 15 factorial, everything over 5 times 4 times 3 times 2 times 1 times 15 factorial, because again, 20 minus 5 factorial is going to give us 15 factorial. Those cancel out. 5 times 4 and 20 cancel out. 3 times 2 cancels out, and that becomes 3. So it's really 19 times 3 times 17 times 16. So we do our calculator, we clear it out. 19 times 3 times 17 times 16, and it becomes 15,504. And again, we're going to use the calculator to show it. 20 PRB NCR 5 15,504, and that's how that works. That's pretty much it. That's today's brief little lesson. Stand up. Nothing really much going on. In addition to that, see the boy in the background blowing bubbles. So yeah, he has his mask on. I might steal that from him for future lessons. Anything else? That's pretty much it. We have 2 more sections left in this chapter, and as I said, we're going to be done with it by Monday, so we'll have a review on Wednesday, and next Friday is going to be our test. So, yep, that's it. And stay safe out there. Hope all is well. Good luck.